Hey guys, thank you and welcome to the webinar. Thank you for joining this session. So just by the way of introduction, my name is Vivek and I lead product at Lightup. I'm one of the co-founders. I also have Manu with me, who is my co-founder and CEO of the company. So in this webinar, we are hoping to give you a good idea of how we are thinking about the problem of data quality for the big data scale. Talk about some of the core principles that we think are needed in order to solve this problem effectively, and then show you how we are implementing them in the product. We'll do this in three parts. So we'll start with a set of slides to talk about the problem, how we're thinking about it, and then go into a product demo, which is a two-part demo. I'll start with an overview of the product itself before jumping into the workflow for when an incident actually happens. And after each part, we'll stop and take questions. So feel free to start typing those questions out, and we'll get to them when we're in the break. And with that, I think we can get started. So Manu, do you want to walk everybody through what we're doing as a company and what Lightup is?
Yeah, absolutely. And hey, everyone, welcome. I'm super excited to be doing this. We are a 2-year-old company. We have been working hard under the hood, building a data quality product for the modern data warehouse. And we're very excited to be showing you what the product looks like, what it can do for you. And this is the first time we're running a webinar. So it's, thank you for being here. This is very special to us. And hopefully you find this relevant and decide to continue the conversation with us. So let me just start by sharing my screen real quick and give you a sense of how we are approaching the problem of data quality for the new data stack. All right. You see my slides?
Yep.
Yeah. Okay, great. So we're at Lightup. We're at lightup.ai. There's a lot of information on the website, so feel free to just hop on there and get a sense of what the company is, what the product is, how it's priced, how you can deploy it, and how you can get started. Or just, of course, feel free to reach out to us at info@lightup.ai. And we'll, of course, circulate a recording of this webinar after it's done as well, so you can get this for reference. So very quick introduction to the founding team. You're talking to me and Vivek today. We're both co-founders of the company. The team is built kind of on two broad skill sets, which is being able to process data at scale and being able to extract meaning out of data. So if you look at the founding team, that's what you see as a skill set. Rajiv, who runs engineering for us, has been in Silicon Valley for a long time. And he was my co-founder at the last company I built, which got acquired by VMware. And Vivek has been processing data for a very long time. So between the three of us, we understand how to process data at scale and how to extract meaning using statistical processing and machine learning out of complex data. Rest of our engineering team comes from a very strong background, brings in rich experience from companies like Pure Storage and VMware. We are backed by some very prominent investors. We have Andreessen Horowitz leading our investment, and then we have another firm backing us called Spectrum 28. So if you ever used a product called PagerDuty, the founding CTO is one of the partners at Spectrum 28. So that gives you a sense of the people associated with the company, how we like to approach things, and what we bring to the table. So with that said, let's quickly dive into why we even decided to found Lightup. It gives you a good sense of how we think about data quality problem, right? So what we were each noticing as founders in our past lives, and what we started to see when we looked around is pretty much every application is becoming data driven. And what that means is that your application is interacting with a lot of data sources, some of which are inputs to the application, some of which are potentially destinations into which the application is producing data. And sometimes you have feedback loops going between destinations and sources. Maybe you're training models out of data that your own application is generating, which eventually feeds back into the behavior of the application, right? And when that's happening, any of those data assets can break in their own right. And that would mean that you end up with a broken application or broken decision making, right? So that's what we mean by a data outage. It's an issue with the data that's interacting with your application, whether it's feeding into the application or coming out of the application. And this could mean things like as black and white as data simply being unavailable. It could mean more nuanced issues like data does not match a certain expectation. You expect it to be, say, a dollar value, you're getting strings, or you're getting values in cents, for example, you're getting euros in, right? Or you expect it to be a phone number, it doesn't look like one. It could be loss in data validity, right? So now you're expecting dollar transactions to be in the range of, say, $5,000, and all of a sudden you're seeing values on the order of $50, right? So for example, if you're an airline, and this is something that we hear about every quarter in the news, where an airline just went around selling transcontinental tickets for 100 the price for hours on end, right? So you can buy a flight from New York to London for $50, right? And that's not what the airline intended to do, but it just happened because someone misentered a dollar to euro conversion rate and got the decimal point wrong. So now you have a factor of 100 sitting in your price value, right? So now data is still available, data conforms to the spec, but data is not valid. You're seeing bad values which have no meaning to this application. Could be on the input side, could be on the output side, but that's also loss of data quality and a data outage in the way we look at things, right? So any of those issues is a data outage. And the kinds of problems where this becomes really challenging to debug is what we like to call hidden data outages, right? So what I mean by that is there's a data problem which is rendering your application behavior bizarre and senseless. But this issue is not showing up as an issue with the IT infrastructure. So it's not getting registered on your infrastructure monitoring tools. And it's also not showing up as an issue with your APM tool, right? So when you look at the application endpoints, they're responsive, you're getting HTTP protocol to function, you're getting data out and all that good stuff, right? But the data just doesn't make sense, right? So that's what we like to think of as a hidden data outage hitting the data plane, which is not visible in other parts of your monitoring pipeline and can go unnoticed for hours, sometimes days on end, right? That's the kind of issues where Lightup can be really useful. Okay. And by the way, please feel free to keep posing questions as we're going along. We want to keep this interactive. You can just type in your questions. They will go to the panelists, so we can just pick them up and answer them as part of the conversation. We hear the same symptom from all around, and this resonates with some of our own experience before we founded Lightup, where you hear a symptom like data just broke in my credit card transaction stream, or data just stopped coming in. I'm a restaurant chain, and I need to be constantly on top of the data that's coming in because I'm running a cash rewards program, and I want to treat that with the same fidelity as a bank would treat their own cash transactions, but data would keep breaking, right? Or data would break and my boss will find it out before me. And worse still, my customer will end up catching it and point it out, which becomes extremely embarrassing for everyone in the equation, right? So that's the issue we see too often. We used to run into that issue ourselves. And we said there has to be a better way of dealing with data issues. We have a lot of structure for IT monitoring on the infrastructure side and the application side, but we should have something for the data pipeline itself, data that's interacting with my application, because that's a single point of failure also at this point. Okay. So what's so hard about this problem? I'm now kind of putting the incumbent solutions into perspective. So if you're familiar with Informatica data quality or Talend or Oracle's enterprise data quality tool, those have been the Magic Quadrant leaders for decades now. And there's something that has changed on those tools, which is why they don't solve the problem anymore. So data quality is not a new problem. It's been around since data exists, right? But something about those tools doesn't work anymore. And that in one phrase is just the scale of data, right? So what we have seen in the last 10 years is 2 orders of magnitude growth in the scale of data, whether it's product data, whether it's customer data, marketing data, whatever it is that the application is collecting or ingesting. And that scale kind of brings a couple of different attributes with it, right? So there's, of course, high data volume. So it makes it hard to apply the same old approach of importing data into a data quality tool and then running your tests, right? That doesn't scale anymore. So that's one big problem, obviously. But then there's this other derivative problem, which is big data now also comes with big cardinality, right? So it's no longer a few master tables in a MySQL database that we're trying to monitor. We're saying we have 1,000 different tables in Databricks or Snowflake, right? And each one is a fat table. So now you have 100 columns each. And I want to make sure that I can monitor all of those entities continuously, right? So I mean, 1,000 tables, 100 columns each, are already talking about 100,000 entities to monitor if you're just doing column coverage, right? Plus the 1,000 tables that you want to monitor at the table level. And on top of that, the data shape is very, very rapidly changing. At that scale, especially with CI/CD pipelines generating data for you, you're adding new tables every day, you're deprecating old tables, changing column types and whatnot. So as this data shape is changing now, you cannot rely on configuring business rules by hand because they will become stale before you even know it, right? So you need a way to stay on top of these changes in data, right? So those are some of the challenges that we are hearing a lot about. If that's you, you would find Lightup very interesting. Right? So how do we approach this problem? So there's a couple of broad components I'm going to talk about. So let's start with the core workhorse of the system, which is a data quality indicator, right? So that's what the system is built on. Think KPI, but for data quality. So if you're talking about Snowflake as a data warehouse, or you're thinking of Databricks with a Delta Lake architecture, and you have a SQL interface, think of a DQI as a SQL query, which is able to push down a data quality check into the warehouse itself, right? So the DQI is now, let's say, defined in the system to measure data volume hour over hour. So our system provides a lot of built-in DQIs for common data quality checks that you'll want to run in a way that they can be directly applied as SQL queries on top of the warehouse. You can do this for unstructured data as well. So if you're just directly ingesting JSON and you're doing more of a lake architecture with some kind of query interface on top, you can now do this for JSON as well. And then if you want to include custom business logic, maybe you want to filter out some amount of data before you measure the data volume, or you want to leave out a certain segment of users, or you want to leave out certain product categories when you're running those checks. Now you're starting to talk about business logic as part of the data quality check. And you can use the full custom DQI interface, which is a SQL interface, right? So you can define your own DQIs also in the system. And you can do this at different stages in the pipeline. So if you're building your pipeline with an ELT architecture, you have raw data landing in the lake or the warehouse, which is successively getting transformed and enriched into the finished data product, right? And on the way, you can attach data quality indicators at every step, right? So now you have monitoring for data getting ingested, data as it's getting transformed through your pipeline, and finally the data that's actually getting served out to stakeholders, right? So DQI is this core workhorse of the system. Like I mentioned, this DQI actually gets pushed down as a query into your data store, and Lightup system never extracts the raw data out, right? So that's how it scales to the modern data warehouse scale, where your data store is already built to manage the scale that you're putting into it, as opposed to the incumbent approach where you will pull out raw data, which doesn't scale very well, right? And you can do this for DQIs across the stages, like I mentioned, which means that you can now also start to correlate issues that are hitting different parts of the pipeline. So you see some downstream effect, like maybe user transactions is a data stream that you're monitoring. You're very sensitive to loss in the quality of data describing user transactions. It can unnecessarily make KPIs look off, right? Okay, so that's one piece you're monitoring, but that might happen because some upstream table at the ingest stage is seeing too many null values, and that is percolating down and making it look like your user transactions went down. So because now you have DQI coverage across the pipeline, you can easily see that these two incidents happened at the same time, and that starts to give you a sense of what caused the other one, right? So you get some root cause analysis out. The system runs as a continuous DQI monitoring system, which will run checks, let's say every hour, could be even every minute or once a day. And then it detects any data quality issues. It sends out alerts on a medium of your choice, right? So that could be Slack, PagerDuty, email, and of course on the Lightup dashboard. Okay. Another component that's built into the system is, of course, the custom SQL interface, which I talked about a little bit earlier. One big feature we built around custom SQL is when you're constructing your own DQI, you can also easily slice out that DQI. So let's take an example to understand what that means, right? So let's say you're a gaming company and you're running 500 different games, and you are tracking the transactions for each of those games coming in, right? A typical data model that we see is all the transactions will end up in one table, because there are aggregations you want to run across games, which are easy if data is all landing in the same table. But then when you're trying to track data quality, it's possible that 5 out of those 500 games are not feeding you data today, and that's what you care to detect, right? I mean, if there's a systemic issue, you will obviously see it on, pretty much every dashboard. But the hard part is when there's this needle in the haystack problem, which is hitting only a part of your pipeline, right? So now the ask here is, when you're monitoring data quality, you want to define your DQIs such that they're tracking each individual game as its own DQI, right? But this data is all ending up in the same table. So how do you do that? Well, I mean, you could obviously go and change your data model and split out the data so that each game resides in its own table, but that's not something you want to do. Instead, what you can say is tell Lightup to slice a DQI defined on the game table by the game ID, right? So it's as simple as nominating a column or a couple of columns, which become attributes on which the metrics will be sliced. So this is something that has proved to be really handy in the field. You want to split by, say, customer, you are a B2B entity, right? Or you want to split by segments. You have a column, and you can just tell Lightup to slice your DQI on a given column or a group of columns, right? So it makes it really easy to map business data shapes without needing to change the data model. And finally, the most important component of the equation that lets you scale data quality monitoring to thousands or 100,000 entities is an anomaly detection engine that is custom designed for data quality kind of metrics, right? So what the system does is, instead of expecting you to sit and write rules or set up thresholds or bounds yourself, the system can profile what a given DQI has looked like in the past, and then use that as a baseline to say if your DQI is still looking healthy as of today, right? And this is aware of seasonality modeling. So if you have different behavior on weekdays as opposed to weekends, or you have different behavior on special holidays as opposed to regular days, the system will know how to model the bound differently for each of those classes, right? There's of course slicing available. So if you're slicing the DQI, this model will be trained for each slice separately. And that's where it starts to become really powerful, because different slices can have different baseline behaviors, right? So unless you are profiling them per slice, you're not going to get the kind of accuracy that makes it meaningful in practice. So that's the big component here that lets you scale out with very little configuration on the kind of cardinality that we're used to seeing, and lets you also stay on top of fast changing data shapes, because the system will pick out new entities and automatically apply a detection criteria and give you a way to tune it if you want to, but at least it will tell you, here's a way to start monitoring this new data entity I just found, right? So that's a set of core components which we'll also show you in the demo. And I'll just point out a couple of other features that I didn't dig detail into. So we have a lot of effort spent into accuracy. We've kind of started with stock textbook techniques to detect anomalies in DQIs, quickly realize their limitations, right? So if you're doing Z-score or MED kind of techniques, they don't really work very well in practice, because data is not as well behaved as you would expect for these techniques to work. We then try to use techniques like Facebook Profit or Twitter's models. They work, but they kind of create this opposite problem of hyperparameter tuning, which also is not something that you want to do on a daily basis. So what we have now is a way of detecting um, degradations in DQIs that is very custom designed to the kind of data that DQI shows up as, right? And so it's just extremely accurate. It's something that we have not seen any other system achieve. We have spent a lot of time working out the workflow in a way so that you can correlate incidents that are happening across different parts of your pipeline. So now you can go from an incident down the stream to something that's happening further upstream and make sense of why a certain metric is broken, right? So you can just narrow down to the root cause without having to send snapshots across Slack and then getting a digital war room in place, for example. You can, of course, stitch up our system into your own pipeline through APIs. That's something that we hear about very commonly. One pattern that we hear about is running checks in line. So you want to fail your pipeline if it fails a certain test, as opposed to percolating bad data through only to discover later that bad data made it through all the stages, all the way to a consumer. So if you want to implement this kind of fill fast pattern or a circuit breaker pattern, you can do that easily. And then we have spent a lot of effort making the system accessible in a way that you can put it in your own cloud, right? So regardless of whether you choose to use Lightup as a SaaS service, or you want to deploy it in your own cloud, or you want to put it in your own gray data center, right? Any of those modes is possible. It takes under 20 minutes to get the system up and running at small scale trial level, right? So you have really streamlined that process. You want to deploy this in a way that you are not boiling the infosec, infosec ocean. You can just do that. Just get the system in and don't have to move any data out of your environment, not even metadata. So we can talk about those deployment architectures separately, but that's something that's also available to you. Right. So why don't I pause there? End of this section of the webinar. I'll take any questions before we move on to a demo of the product.
Sure. There's a bunch of questions that came in, Manu. So
Okay.
the first one is around data sources that we support. And it's I got a few different questions on that. So one is generally what data sources are supported. There's a specific data source that was brought up, which is Microsoft SQL Server. And then there was a question around Kafka as well. So there are things where Kafka is mentioned as one of the supported platforms on the website. And is there a way to configure observability rules on Kafka? For example, started message flew into the Kafka topic, but there was no corresponding completed event that was published in time. So those kinds of checks want to be configured on Kafka. So generally around support for these data sources and how we're thinking about them.
Got it. So that's, I think, a very pertinent question, especially the part about streaming. So let me take the first question first. So we can do SQL Server. SQL data sources are very easy for us to add. So in particular, SQL Server is something that we're getting requests for. If that's something you're interested in, it'll take us about 3 weeks of lead time to provide support for that connector. The full list of data sources is in our user docs. Vivek, maybe as part of the webinar, you can just paste the link. If there are other sources that you're interested in, we can have a conversation and we can give you a sense of do they fit our roadmap or not. Usually SQL speaking sources are fine, and we have been very open to implementing support for them. Streaming sources is an interesting question, right? Especially the open close check that you're describing. So that's also something that comes up often. We have implemented data quality checks on streaming sources. So we are officially able to support Kafka and segment both. The way we do it internally is that we will warehouse the data, but that's transparent to you. So as far as you are concerned, we just look like a Kafka consumer, just directly consuming from a broker, right? And then what we do on our side is we will warehouse it in a way that's efficient, both from a cost point of view and performance point of view. If latency is a concern, we can discuss the SLA that you need. It's something we've been able to do. The open close kind of a check can be done very easily once the data has been put into a table format. Another way we can approach that is if you have support for KSQL already on top of your Kafka instance, we can directly hook up to KSQL without going through that intermediate step.
Okay. And the second question that came in was around the DQIs or observability checks. So generally, can you create DQIs automatically by looking at the data or suggest observability rules using ML?
So I think there's two parts to the question, if I understood it correctly, right? So, and Vivek, feel free to chime in, right? Because you're very familiar with this part of the product. So there's DQIs, and then there are alerts on DQIs or anomaly detection criteria. So DQIs is they're built-in DQIs for tables, and they are tied to the type of the column that we're seeing in the table, right? So we can look at the schema, and then if you have a numerical column, there's a certain category of DQIs that gets enabled. If you have a categorical column, a different set of DQIs make sense, and those get applied already. So we can of course just apply DQIs automatically, depending on the table schema at hand. In terms of alerting criteria, that's something that our system can do. And we have a backtesting workflow, which we didn't talk about. So the way it works is we can set up alerting criteria automatically. and then tell you what the performance is expected to look like based on, say, last couple of weeks of data. So for example, if one of the system suggested rules is alerting too much, you will see that even before you make the rule live. And then you have an opportunity to first improve the configuration on your own before you make it live, right? And for the most part, let's say the configurations make sense, those can be enabled right away after you have inspected the backtesting performance. So to answer your question, yes, we can entirely automate the process of both setting up DQIs and alerting, but you do have a way to make sure that the system is not going to produce garbage, and you have a way to tune it if needed before you make things live. Anything you want
Just
to
to
add,
just
Vivek?
to
Yeah.
Yeah, so just to add to that, so I'll show each of these components in the product, and a good way to think about it is in these two components. One is what metrics does it make sense to track for a given data asset, and second is what bounds to apply when you're trying to detect things. And I'll show you both components in the demo itself. So a quick follow-up question, Manu, and then we'll move to the demo itself. In response to the answer to Kafka, the question was that means Lightup will store our data, which might raise concerns with our security and compliance teams.
Mhm.
Do you want to take that one?
Yeah, sure. So the way, I mean, so that's an ephemeral store, right? So we can put retention bounds, just like you have retention bounds on your Kafka broker. So that's one way to approach it. Usually that works from a compliance point of view. Um, your head of security may still have issues with any data being stored at all. So what we recommend doing for that scenario, we can of course discuss this offline, but one of the ways we can do this is we do the entire build out in your VPC. So that way, the data never leaves your environment, which is usually a very easy way to get InfoSec approval. Anything else you wanted to add, Vivek?
Nope, I think that's exactly what I had. Okay, so let me jump into the demo then. This is good. Yeah, just keep it interactive, guys. This is really good, and we'll do a deeper dive into what the questions are in your mind. But here is so I'll start with so the two components that we talked about, right? One is what are the out of the box data quality indicators that you can start monitoring with Lightup, and then in part two I'll talk about what happens when you detect an incident. So starting with data quality indicators, here I have a data source configured, and there's a bunch of data assets that each data store represents. So there is at the data source level, you're tracking what tables got added, what tables got deleted, right? And if a table was inadvertently deleted, this is where you'll find out about it. Uh, and then moving on to the tables, you could have issues where data is not available. So there are two components to data availability that we track. One is the overall data delay, which is the time since the last event timestamp. So for example, if a pipeline fails to execute, you will see that typically there is some data delay that you register, and all of a sudden it starts going up. That would mean that the pipeline failed to execute and no data is coming in. So data is not available. So even though the volume drops to zero, your problem is the data delay itself. Now, there could be a case where the data delay itself is fine. So you recorded some data, but you didn't record the right volume of data. And that's when a data volume comes in handy, which is the second component of data availability, which is row count per unit time. So in this case, it's an hourly metric that looks at data volume every hour. And even though we did register values, so it's not zero, but you registered fewer values than expected for this time of the day. And so that's another kind of data quality issue that Lightup can automatically detect. The third thing that you can detect at the table level is the overall schema of the table changing. So by schema, I mean the data type and the number of columns. So in this case, for example, a column was removed, and this could be a problem for downstream consumers if they were not notified about it. So this is something that you can detect using the schema metric. So now if everything is healthy at the table level, there's a bunch of metrics that you get out of the box at the column level. So let's take a look at a numerical column first. So for a numerical column, we track two things. The first thing is the overall distribution of the column. So this is the percentiles that the values, percentile that are being registered. So for example, in this case, you see that the data distribution used to be really tight, and all of a sudden it has moved. So this could be thing like you converted miles to kilometers by mistake, or dollars to cents. Those kinds of issues would be found here, and you would be able to detect and alert on those. We also track the overall missing values for a column. So there could be a case where you're just registering a bunch of null values because of some issue in the upstream pipeline, and those would be caught here. Now, if your column is categorical, we track distribution, which means the relative frequency of each of the categories. So in this case, for example, you have these 5 distinct categories showing up for 5 different game types: rummy, slots, blackjack, baccarat, and poker. And on June 6th, we detected an issue where we said where the overall distribution changed. Now, if I compare this to the last day, you can see that the others increased, but it's Rummy that showed a severe drop compared to what it used to be. So if a category all of a sudden stops recording values or shows a lower than expected relative frequency, you'll detect it here. And if a category completely drops, you will find it in the list of categories. For example, if you're getting data from 50 states and all of a sudden a state stops showing a value, you would register it here. And of course, we track missing values as well. So if the null values spike for a categorical column, you'll find out about it. So those are the DQIs that you get out of the box. This is a list that we are growing based on customer feedback, but this gets you started with the most basics, and in many cases a very good set of checks to get started with. But then we understand that every business has their own specific checks that you would want to run, and for that we provide custom metrics that you can instantiate. And this is done by using our custom SQL interface, where you can write whatever business query that you have that you would want to write on Lightup. And then we also give you a way to monitor the data at a fine granularity. So what I mean by that is there could be a table where data for several different entities is ending up, each of which could break in its own right. For example, in this case, the customer chose to break it down by the OS version. So this is the average order value that is being registered by the OS version. Now, if there's a problem specific to a certain OS version, it could register a drop in average while all the other OS versions are doing fine. There could be a universal problem where all of them are affected. But by using this concept of slicing, you're quickly able to configure a single metric that then creates hundreds or thousands of submetric depending on what your granularity is, and Lightup then automatically starts tracking them at that granularity. So now you're able to find issues which would otherwise stay hidden if you were to aggregate it as an overall metric. So by using these two components, you're able to now configure any custom check that you would like to configure and start detecting issues. The flow works similar to what an out-of-the-box DQI looks like. Just in this case, you are defining the DQI, and then you start tracking it on the dashboard. And once you hit monitor, you have the option to set up your own thresholds or let Lightup detect issues using ML-based anomaly detection. So that's the basic set of DQIs that you get out of the box and how monitoring looks. With this, I would pause and see if there are questions.
A couple of questions came up, Vivek. I'll just read them out to you. So one question is about the query load. So we talked about SQL queries. So what is the impact on the data warehouse of running those DQIs?
So the way we approach this problem is we're running time window aggregation queries. So for example, if you're looking at data volume, it's the row count. If it's an hourly metric, it's the row count every hour. So those queries typically have a time bound with a start time and an end time. So if the table is already indexed on time, we are not causing a full table scan. And that we've seen to be very effective in most cases. So we have had customers who are using one of the incumbent tools where what the tool would do is run a select star and result in a full table scan. And when Lightup was used to run similar queries, those DQIs didn't even cause a blip on the DBA radar.
Okay. And the other question is around configuring on a large number of tables and columns. So how does one do that if you have thousands of tables? Is this automatically set up by the system, or this is something that you need to do by hand?
So we realize that these are still SQL queries running against your DB. So what we provide is a bulk configuration interface. So a bunch of these metrics, you can just mass apply to all the tables. So the way you would do it is you would select all the tables of interest. You could filter as you need to get to the list of tables that you do want to monitor, and then turn on profiling, which is when these metrics will start getting tracked. So with a few clicks, you will get started. on all the tables of interest.
And one other question came in. Will you have customer references available if we need them?
Definitely. So, I mean, we can chat offline about that. Why don't you reach out to us, and we can set up those conversations as needed. We also have case studies that we've published that talk about some of the specific ways in which the customers are using Lightup. Uh, Anything you want to add to that, Manu?
No, I think that's fair. So we can definitely talk one-on-one about the customers that we are working with. We can even show you some of the results we have achieved with some large customers in the US. This is obviously not something we are ready to share publicly yet, but we can definitely show it or discuss that one-on-one. So another question that came in is, who is a typical user of Lightup?
So typically, what we've seen is depending on the maturity of the company, there is either a data quality lead who has been using one of these incumbent tools to run checks and is quickly running out of steam, both in terms of the kinds of checks they can run and the number of checks that the business is requesting. And they would come in and they typically know some SQL, right? And have been using tools like IDQ and Talent. And then there is another user persona that we've seen show up in the more modern companies who are thinking about data quality for the first time. And there it would be the data engineer who's maintaining the pipeline. And they've been charged to make sure these thousands of tables, I mean, because the tables grow very, very quickly. And then it's always data engineering job to make sure everything is up and running and healthy. And so those guys find Lightup very, very useful to keep a tab on all their pipelines.
Yeah, and what we also see is kind of that's the first responder user that we just described. But we also see, say, the analyst being brought in or a product manager being brought in as an expert. So if let's say you have an issue like transaction volume is starting to look low, and maybe that's a data quality issue, maybe it's not. So maybe you're dropping data and so transactions are looking artificially lower in volume, or maybe there's something genuinely wrong with your application today and people are just not engaging with the application. So one is a product issue and the product owner is the best one to judge that that's the issue. The other one is the data quality issue where the data engineer is both equipped to judge as well as go fix the issue. So that's the collaborative angle that we have seen happen, which we enable on the platform, so that people can come in, pull in their hypotheses, pull in different kinds of DQIs that they want to stack together, so they get a sense of what are all the relevant metrics looking like at this point in time. And some of them may not be broken, but you can still bring them into the same context and kind of create a case report that gives you a complete picture of all the DQIs that matter to this conversation.
Are there any other questions? Otherwise, that's a very good lead into the next section.
Yeah, I think we can go ahead.
Okay, so what happens when an incident occurs, right? So first thing is, as Manu mentioned on the slides, you can send out an alert on an alerting channel of choice. This is how an alert would look like. It'll tell you what happened, what was detected on what metric. And you have three options. You could accept this incident. You could reject it right away if you know something about it. But in most cases, you would click investigate. And investigate would land you directly into the incident itself, which will have information. For example, in this case, what we see is data volume dropped on a table called paid transactions in the source demo DB. And it was detected by Lightup, and this is the incident that got highlighted. So now just to talk about the how accuracy of detection is important, let me show you how this signal looks like. And maybe I'll zoom out even a bit more. And what you'll see is there's a few things happening, right? There's this metric has a daily seasonality. There is a trend. I mean, values can change a bit from day to day. So this is how most real businesses data looks like, right? You send out a marketing email, more users show up than expected. COVID happened, you might see a drop in users, right? And there's always seasonality. Weekends look different from weekdays. Even within weekdays, you see different values, right? And what you're looking for, and if I were to show you this on a chart, right? And I asked you what is the data quality issue that you would want to be marked, you would likely mark this. And this is because that's what your intuition will tell you, that it's a sharp deviation from what you expect that signal to look like at that time of the day. It's a sharp change. Now, notice, I mean, if you used textbook techniques like mean plus minus 3 sigma, or even something more sophisticated as Facebook's profit, it's taking into account this trend and this seasonality. And what it would mark is, I mean, it could mark issues where things are looking much higher than normal, or this is looking way lower than what I've seen in the past. But this could be a minor thing for the business itself, but not a data quality issue. So what we have purpose built for Lightup are these algorithms that we have got to after having iterated on multiple times using it on real customer data is algorithms that can pick up things like this, right? And now you suddenly have the power to go apply it at scale, right? If suppose, I mean, just to talk a little bit more about that point, suppose you have thousands of signals that you're tracking, right? Thousands of metrics. Now, if even 1% of them alerts, I mean, that's a lot of alerts for you to be paying attention to. So you really want to make sure that you have a good number of them are real alerts. And that's what Lightup lets you do is actually find out stuff that matters. So once you've taken a look at this issue, you can then try to quickly dive deeper into it, right? And that is two components, right? This looks like a real issue. Now the question is this a real business issue where the paid transactions actually drop, or is it a data quality issue? And that's where the collaborative angle comes in. In this case, this is a table that is called paid transactions. It's filtering on the raw events table, which has the raw data coming in for all the different games. So the scenario is that of a gaming company. There's data for 50 games ending up in the same table, and then based on that, you're successively transforming it to create these different tables. And one of them is paid transactions. So now, in addition to the incident itself, we also show you what metrics registered an incident at the same time, and that's under correlation analysis or co-occurring incidents. What this lets you do is quickly get an idea of what else is broken in the pipeline. So if it's a downstream issue that you're looking at, it gives you visibility into what may have been broken upstream that needs to be fixed that may be causing this issue. And if you're looking at something that is upstream, it will quickly let you assess what the downstream effect looks like. And that way, you're able to pretty much traverse the lineage based on the principle that all the incidents, all the parts of the pipeline that are broken at the same time will register incidents that happen at the same time. So now if I look at this correlation analysis, it's broken into three parts. You can find incidents that happened before, at the same time, or after this incident. And what I notice is there is a missing value spike for the source demo DB, for the raw event table, for the column transaction type. So now this seems very relevant because this is the column that I'm using to actually filter and create this table. And so Lightup learned the expectation for missing values. You can notice that you can see non-zero missing values, and there is some expectation based on past. But right now it's spiking more than normal. And so because of which this table is affected. And Lightup actually goes a step further. If you use the slicing dimension, you could, for example, slice it by game type. And in this case, what Lightup is saying is all the other games are healthy. It's only Rummy that is noticing this spike. And so that's the issue to go fix in the upstream table. And you're quickly able to build tables like this. You can bring in other charts into view as well to create a full report. You can leave comments on this report. And this becomes your collaboration platform, and all of this persists. So now if you were to put this into a ticket, this is where the relevant folks would come in, validate that it's an issue, and go work on fixing it. So lets you do that collaborative part really effectively while traversing the lineage.
So Vivek, one question came in. I think you partly answered it. So is there an example of a created report? I guess you're showing us one right now, where different stakeholders can come in and collaborate. And maybe you can also touch upon what happens. I mean, the fact that this is persistent, and then you can share this, right? So this becomes your case report.
Right. So you can just pretty much share this at this point. You can add charts to this, you can remove charts, you can add comments, and this is persisting. So anybody who clicks on this incident from now on knows that somebody has put this curated view together as a root cause chain. If there are any comments, they're also visible to them. And so at this point, this pretty much becomes an incident report.
So this incident started with that top line metric of paid transactions as what cited this incident, right? That's the incident we're looking at. At that point, that was the only chart on this report. And then collaboratively, we said we want to bring in some other incidents that the system found which were co-occurring. So that's your next incident of transaction type that you're showing there. And then you have a cut of that incident, which gives you even more resolution on a game type rummy, right? And then you also mentioned that you could bring in healthy metrics into view, right? So if I have, let's
Correct.
say I'm a product owner who just came in and I
Yeah,
have
you
a
could bring in
hypothesis, right?
any metric that we're tracking, you
And
could bring
say
it
I
into
want to
view.
look at a different game because I want to make sure that this issue is only impacting one game and not the other games, right? Because the system didn't cite other games.
Correct.
So I could do that too.
Yes, correct. So here, for example, you could just bring in a game called Bakra. And once you add that to view, you should be able to then take a look at the report and see that Bakra is healthy. So you could do all of that.
All right. And this report persists, right? So if now I have added Bakra, it stays there. So if I grab this link and share it with someone else, they will get all those 4 charts that I added to the context. So they have the same picture that I signed off on when I
Correct.
triage this issue. Okay. I think one other question we're getting is what can you do in terms of responding to the incident? Is there some support that the system already has built in?
Yes. So you could accept or reject an incident. So rejecting an incident would do two things. It will remove it from your view, and it would also tell the system that this is not a relevant incident that you want to see, and the system will calibrate in response to it and get more accurate in the future.
So you can do accept, reject, and then this also kind of hides an incident, basically creates an acknowledgement, right? So it stops showing in the system because you know that you have already seen it, acknowledged it, maybe someone is already working on it. Okay. Another question that came in is about accuracy. So what number of incidents identified by Lightup versus incumbent solutions look like? So is there some demo we can do about this being more accurate than incumbents or
So,
competitors?
so I mean, we can talk about that in a one-on-one session. We can show you what we've been able to do for some of our customers. But generally, a good rule of thumb is what we've seen is uh, that typically for these kinds of signals, we've seen anywhere between Manu, correct me if I'm wrong, but we've seen anywhere between 50 to 80% false positives, right? And Lightup was able to cut it down to about 10%. So 90% of the incidents were very, very useful. But more than that, I think for incumbents, right? Especially if you're talking of tools like uh, IDQ or Talent, I mean, some of these are not even supported. So there were issues that were just flat missed. For example, if the volume didn't go to zero and the volume went down a little bit for a particular day of the week, that's not an incident that we saw any of these tools detect. And for some of our bigger customers, I mean, we within a week we went back with results that they didn't know actually happened, and these were their production tables, right? Bread and butter tables for our analytics. We were able to find issues that incumbents just missed left and right.
Yeah, I can show a slide quickly that we
Sure.
had put together based on comparison with some stock algorithms. Just
Sure.
bring that up real quick. So here's a view of some of the techniques that we have talked about as stock techniques, whether it's textbook techniques or things implemented as part of forecasting algorithms. So what you're seeing here is one example incident of data quality, actually two different examples, right? This is on a gaming customer's real data. This is the data quality incident where there was a sharp dip, and then similar incident happened at another point in time as well. And you're looking at a longer time scope here where you see these sharp dips show up, right? Sometimes you will see a dip all the way down to zero. At other times, that's not what happens, right? But you still see this very significant drop. And those are the data quality issues that they intended to catch. And what you're seeing here is what our sharp change algorithm is marking, right? So exactly the kind of problems that you would want to catch, right? Here's what would happen if you learn the band with the z-score implementation with mean plus minus sigma. So what you see is that in the early part of the month, it was doing pretty good. It was catching this incident. It did miss a couple of incidents because this still fit within the expectation band. So, there's a trade-off between false positives and false negatives here. And then you see this algorithm just go entirely bonkers towards end of the month, right? And that's when there was a macroscopic shift in the trend line. So now these levels have shifted out of the band that was learned earlier in the month. And now, so this rule has basically become stale in its criteria, and it's just alerting you all the time. And then another one that we have seen people use very often is a day-over-day difference kind of algorithm, and then you do a mean sigma expectation on top of the difference. Here's a view of the performance of that same algorithm. The bands are not obviously visible on the same scale because it's day-over-day differencing, but again, you have a trade-off between um, false positives and false negatives. So, either you end up missing some of those incidents, or in order to cache them, you end up absorbing so much noise that it's very hard to use the system. So hopefully that gives you a sense of the difference in accuracy. One other question that's coming in is about the lineage here. So for this correlation analysis, do we need the lineage, or is that something that we have to integrate with, or the system is working without any lineage input?
So right now, the system actually works pretty effectively without any lineage input, based on the simple principle that anything that affects an entire pipeline shows up as co-occurring incidents. And with that, and your knowledge about the pipeline itself, you're able to traverse it pretty effectively. That's what we've seen in the field. But we also realize that lineage is an important part of the overall data governance and data quality, or how different stakeholders interact with the quality of data. So we are actually actively considering integrating with some of those lineage and data catalog tools, and as a
Just
way
like
to
tools
also
like
surface
Elation and
Mhm.
Colibra, like Amundsen
Elation,
potentially.
Calibra,
Mhm.
Amundsen potentially. And the idea is to make Lightup's insights available on those tools, if that is the first place where a lot of users go for insights on data, right? And then you can always come into Lightup once you start using a data source more regularly. So that's a direction that we are thinking about. We have not. We think lineage is a problem that is best solved by and someone independently. It's a problem in itself to make it work across different data sources, right? And not a problem that we are trying to tackle, but we're able to get incident resolution, which is what we're trying to get to without that information. Okay. So if there are no other questions, I think this was great. We are able to get to most of the questions and give you a good view of what Lightup looks like, right? And as next steps, you can of course reach out to us if you have more questions, or if you want things like customer references or want to do a one-on-one session. If you want to try out Lightup on your data, just click free trial on our website, and we've made it really easy to get you started for all the different kinds of settings. So if you wanted to try a SaaS version, you can do that. If you want to do a hybrid deployment, we can get you up and running in no time. And what we've typically seen is given the amount of work that we've done on making the system easy to deploy, as well as on the algorithms and on bulk enabling DQIs, you start to see value within the week. So it's very little time commitment in that sense for you to get a good idea of how Lightup works on your data. And even if you're not ready to try that out and you want to try it on some demo data sets, just sign up for a community version. I'd invite you to our community cluster with some demo data. And there you can experiment with any public data sets that you want to bring in, or use the demo data sets that we've already available. Yeah. And yeah, thank you so much for attending this session. And I look forward to hearing back from some of you.
Yeah,
Thank you, guys.
thank you everyone for joining in, and we will share the recording with you after the event, and feel free to reach out to us. But great to do this session. Thanks again.
Yep. Thank you, guys. Bye.